Good afternoon and welcome to this afternoon CPD session on gas detection, how drone-based sensors have revolutionised monitoring. This session is going to be recorded, so please keep your cameras turned off and your microphone muted. You are very welcome to ask questions via the Q&A section at the bottom of your screen, and we will have time at the end of Jonathan's presentation to take the time to answer questions. So without any further ado, I'm going to share Jonathan's presentation and we shall make a start. We're delighted that Jonathan can make it here today because he's actually out in the field at the moment. So we're delighted that he's here and able to take us through this. He's extremely passionate about his subject and we are, as I say, very pleased to have him here. 2 moments.
Hi guys, right? Okay, I'll take it from here. So, yeah, welcome to the webinar. Yeah, we're this is the second of two, and hopefully, this will give you some real insight into what the options are for gas detection. This is really kind of aimed at people with minimum knowledge of gas or leak detection. And people like perhaps in working for the operators or on sites who have perhaps been looking out for different ways of detecting gas, and obviously those people that are on the schemes for greenhouse gas emission reductions, then this sort of thing it would be quite interesting. Okay, so a little bit to start with. Next slide's about myself. So let's switch to that slide and. Yeah, let's go from there. Elena, can you change the next slide, please? Thank you. So yeah, about myself. Yeah, I'm a chartered marketer. I've been working in marketing for about 20 years, but predominantly in the power and energy sectors. So I've worked a lot, well, quite a bit actually in power engineering, both in product management, product development, and product and launching of new products. So when I say products, I mean technical products, complex products such as gas turbines. I spent 8 years of my working life working for Doosan Babcock in asset integrity management, both over oil and gas and power generation. And I was, most people who know anything about asset integrity management, it is all about a lot about survey and inspection. So I did a lot of work in that area. Started working with as a reseller for UGCS and looking to get support from other OEMs now. I've been doing that for about 2 years. So yeah, that's where I am right now. Next slide. So just a few of the learning objectives. It's good to sort of cover these first so that we, hopefully you can come out at the end of this saying, yeah, actually, I can tick all those boxes. So yeah, first of all, it's really good to look over the greenhouse gas context in the UK. So what's actually, the figures we look at are 2019, but there's not that much, there is some change, but in relative terms, it's a really good picture on where we are. Then we look at some drone technology and the uses, and we're just going to concentrate on a few there. The benefits of using drones, again, a general look at why bother using drones in the first place. And then I've also included a section on scope and procurement, because I think that's really important. Certainly if you're going to be procuring services, if you're a site owner or an operator, it's good to know, some start for tens, so that should be helpful. And then, yeah, part of that, in some respects, is a selection of service providers. So we'll look at that as well. We'll look at a case example. So it's a case example, and it's some of the economics of it. And then I at the end, I would like to touch on just some future developments to look out for, things that we should see soon. So next slide. So greenhouse gas. So the UK context. Yeah, next slide. So this is just giving everybody an overview of emissions from in the UK by gas on the left hand side here. So as you can see, that out of the 100% total, 80% is carbon dioxide, 12% methane, nitrous oxides 5, and fluorinated gases 3. So fluorinated gases will be the things such as refrigerants SF6 that are used for insulation, yeah, we'll touch on those a little bit later. But note there that methane 12%, it's the second highest emissions, and man-made in the most part. So yeah, it's something that we've really got a part to play in there. We'll touch on that later. So on the right hand side here, you can see that we've got a trend of different greenhouse gases. And you can see there, actually, if you look carefully, you can see that the fluorinated gases actually increased over from 2010 sort of onwards. It started to jump up, and there's a reason for that. And I'll touch on that a little bit later. Carbon dioxide coming down, and sort of methane has come down significantly, and I'll touch on that as well, why that is. And that's actually a success story, and we'll touch on that. The bottom graph table here is showing what's called GWP. Essentially, that is how many times more potent is it causing the greenhouse effect than carbon dioxide. So it's, how many times more potent is it than carbon dioxide. So if you look down the list, you'll see, for example, methane 84 times more. You'll see some of the fluorinated gases. You've got here sulfur hexafluoride, SF6, which is used a lot in transformers. There's a lot of issues there at the moment with older transformers because it's used as an insulator. Very potent indeed. Yeah, so that just sort of gives you an idea of how much potent they are than carbon dioxide. We hear a lot about the carbon dioxide, but not all the other gases and actually what they're doing. Yeah, again, you're going to get a copy of this, so you can see here with how long do they hang around for? So half-lives and so on. But yeah, for your reading pleasure. Next slide. So everybody's aware of the Paris Agreement 2015, and possibly you might be aware that we have sort of national contributions at 5-year intervals which have to be provided. And so obviously that's been, the requirement to meet targets now is with everything that's going on in the world it's being pushed right into the front of our minds, and certainly those of the politicians. You'll also be aware that we just recently, the UK signed up to the US-EU Pact to reduce emissions of methane by 30% on 2020 by 2030. So again, that is something that's, over the next few years, there's going to be very much more emphasis on how we are doing that and where the sources of emissions are. Next slide. So on that point, it's really a case of action stations, because we need to do something. And, it's going to be a question of regulation or self-regulation, a mixture of the two. I mean, if we, what you could go from one side in, like we've got in the United States, where everything is regulated, to more of a self-regulation and a permitting sort of process that we have in the UK. And how we're going to fall back, how this is all going to work, I'm not too sure, but I would like to think, in the most part, it will be self-regulation, and it'll be really just there'll be more emphasis on companies and organisations proving that they've done their job and reduced their footprint, and will hopefully be ahead of the curve by putting things in place. So, there is these schemes, CDP schemes now that are sort of like substantiate ISO 14064. For greenhouse gases, being able to record and prove what your greenhouse gases were and what things you'd put in place to reduce your carbon footprint for whatever gas that is. And these, a lot of companies now are signing up to voluntary verification, CDPs as they're called. And kind of what we're going to talk about today also falls into that, because it supports that. It allows you to show that you're looking at new technologies and you're looking at ways to, for example, just to reduce your greenhouse gas emissions. Next slide. So this chart here is really to give people an idea of where our gases have come, where they've come from, and actually where the trends are. And as you can see there, on the left-hand side, you can see the different types of gas emission, and effectively got methane and where it's coming from. And I say methane because it's really, as we saw, methane is kind of like the main kind of, you know, the main issue we've got. But you can see here, if you look at yellow, for example, yellow, methane coming from waste is the largest source. Let's have a look, and also I think you'll find agriculture is a large one, and I know that there are DEFRA a lot of programs on at the moment to look at food and how it's put together, how it's made, and also how to manage manure and how that's processed. So there are a number of things in place to reduce our methane emissions, but on the whole, as you'll see, and I mentioned it earlier, the methane emissions have actually come down quite significantly, and it's mostly part to the landfill industry that have really stepped up to the plate and have reduced their emissions by 60% over, you know, since 1990. So it's a really good success story. Next slide. So why methane? Why is everybody jumping on methane? Why COP26 did everybody sign up to the methane? So there's some reasons here. The first one is that most of methane is anthropogenic, so it is man-made. It's through our processes and what we're doing in our activities. It is a super polluter. So if those that were keen of you, if you remember back to the table, it's 84 times more potent than CO2 at causing the greenhouse effect. So essentially warming the planet. So there's another reason. And also another key one here is that these methane emissions could be reduced quite easily by operators and site owners employing sort of ongoing leak detection, ways of monitoring, mapping, and identifying fugitive emissions. So they could be prevented, and it's kind of like almost like a low-hanging fruit. And as it's there for the taking, we can reduce our methane emissions quite quickly, and we know that it does have a significant impact on global warming. Next slide. So some drone technologies and uses. So what I'm going to do here is I'm going to go through the main technologies, and there are some technologies that I won't mention, but on the whole, these are the main technologies that are worth knowing about. If you're going to get into this line, if you're going to look to procure these kind of services, what I'm going to talk about now is going to be what you're going to rub up against. It's going to be these kind of technologies. Next slide. So the three systems that I want to talk about today are sniffer systems, optical gas imaging cameras, and TDLAS systems. And I've got a page on each, so we'll go through them in turn. So next slide. So sniffers or sniffer systems, sniffer drones, they're used for gas detection concentration. They do have a snorkel, and if you look in the top right hand corner of that picture, you can see that you can just see the snorkel coming out of the front of that, what I think is an M210. And what it's doing there is the drone needs to fly through the glass or the plume of the gas. So you can imagine that in some circumstances and also in some applications, that might not be the best policy. If you've got large releases of methane or methane leaks, it might be that your site owner or your health and safety team will say, look, there's no way we're going to let a drone with motors and electrical components fly through that. So it's not always the right horse for the course, but what it does do is it will allow you, certainly for inert gases like CO, C12, O2, NO2, it will allow you to fly through these gases and get good readings, good levels. The good thing about this technology is that you can layer with the software that comes with it. You can actually layer the different gases one on top of the other. So if, for example, you were flying down a road, and which is where this is used quite a lot, actually. It's used for measuring your carbon dioxide and your nitrous oxides. If you're flying down a road, what you're able to do is layer on top the NO2 readings with the O2 readings and so on. So it gives you a great picture of where all the different gases are along your road network, let's say in a built-up area. So that's quite useful. I've also seen it used in emergency services as well. So where you want a drone just to detect traces of a toxic gas, then or a gas you certainly don't want anybody to be anywhere near, then it can do that, and it does come with an explosion limit sensor as well. But again, like I said, that might not be enough to satisfy health and safety teams. On an M300 RTK, which is a standard commercial drone at the moment, we're probably looking at in the region of 20 to 40 minute flight time, depending on the conditions, of course. As I was saying earlier, the software that you get with this system is fairly extensive, very easy reporting. One of the great things about drones is a lot of the reporting side of it is taken up by the software, making it very easy to write your own reports. So hopefully that gives you a good idea of what a sniff is all about, and that there is limitations to it, and as much as you've got to fly it through the gas itself. And again, that could cause issues. Next slide. So if we go back one. No, go back one to, yeah, next one, sorry. Yeah, that's right, okay. So yeah, so the next slide is all about optical gas imaging cameras, or people call it OGI. This type of thermal camera, these are essentially looking for what we call closed sources. So what we're talking about here is complex infrastructure, like you'd find in oil and gas, refineries, and you would find them in petrochemical plants, pharmaceutical plants, complex manufacturing plants where you've got pipe over pipe, and usually at high pressure or high atmospheric pressure. So you need to be able to see exactly where the system, and the imaging camera is able to actually see that gas coming out of the pipe. And because it can detect it detects it using the different wavelengths of light, and the differences in that light coming back to the camera. These cameras tend to be very, very specialized, quite expensive equipment, to be honest with you, can be quite heavy, and as a result of that, they do tend to be they do limit the flight time of the drone to some extent. But they do vary in weight, from a couple of kilograms all the way up to much heavier than that. Where you're talking in some cases 3 or 4 kilograms for the real specialized systems, and you need a larger drone than the one that I mentioned earlier, which is the M300. On the whole, I think some of these cameras that I've seen, you're probably looking at around about, certainly if you're not using an M300, which has a longer flight time, you're looking around 20 minutes. I would say 20 to 30 minutes, even with an M300, if it's able to fit on at all. It might not be, simply because it's a lot of them they wouldn't fit on. So there's only a couple that I know in the marketplace that have actually been designed for the M300. Again, if that's of interest, then please come and talk to me, and we can sort that out. As I mentioned before, these are great for actually seeing where the gases are coming out of the pressurized container or pipe system, again, like with sniffers, the live feed, you've got live feed, you've got a great transfer onto different networks. So the software allows you to report, pre-fill reports, and you can do some very good post-flight analysis as well. So the software is keeping up with this kind of technology, and in fact, that is one of the great features of all these technologies is the software side of it. Okay, next slide. So the last technology that I want to spend some time on talking about is TIDLAS, which is it's a bit of a mouthful. So TIDLAS is much easier, but tunable diode laser absorption spectroscopy, if you can just about say that. This kind of technology, I've included this because we've mentioned methane quite a lot, and the main way that for detecting gas, certainly not only from open sources, but you can also use this technology for closed sources like large pipelines, for instance, is this kind of technology. So methane concentrated mapping and leak detection can be done with this technology. What this how this system essentially works is it looks through a column of air underneath the drone, and it then works out using the light returning from a laser that it fires out. It then works out estimates how much ppm is in that air column, and it's that ppm times m meter column, which is recorded and is given to the outputs. So that's what's used. As I alluded to, it is to detect methane, and the great thing about this kind of technology is it only detects methane. So there aren't any false readings, false positives or anything like that. It will only detect methane because of the way that it's set up. It can be sort of doubled up with other things like RGB cameras, thermal cameras. So you can actually have a camera and this system at the same time, as long as you've got the payload capacity. And you have to be aware of your own flight time as well. You don't want to put too much payload on, otherwise you won't benefit from the flight time. You'll be changing batteries all the time. But certainly with the system that you can see there, the methane Falcon, you're looking at around 40-45 minutes flight time with an M300, which, like I said before, is the standard for the commercial drones, well, commercial drone industry now. And it gives you, really good. You can do a lot of work in 45 minutes, which we'll touch on a bit later on. But essentially, this kind of technology, you can see in the bottom right-hand corner here, we've got we're able to put together a orthomosaic, which is basically lots of photos of your site all stitched together. That gives us a real-time visualization of your site. We're able then to overlay that with CAD, so a CAD that has been provided from if you're a site owner or an operator from yourselves, which we will then lay down, or the service provider will lay down on top of that orthomosaic, and then on top of that we lay down the actual methane data itself, giving you a really good overview of all what the methane levels are. And it's become a really useful tool. As before, software is again live feed software, interactive mapping with this technology. So being able to go into a spot on the map and see things like what the methane levels were, what the wind speed was, pressure, and all these kinds of things. It's becoming quite clever and really, really useful for site owners and operators. Next slide. So some key benefits then of these kind of technologies. Next slide. So of the drone pilots of you out there, this will be sort of second nature to you. You'll understand this, what I'm about to say, and it's something you'll be very well aware of. But for those who aren't, it is actually quite useful to go through these. Because there are some real benefits from using drones. And the first one here that you can see is accurate survey repeatability. because drones can be set up with RTK accuracy, which is like centimeter accuracy, you can repeat, and also you can store the survey route or mission, if you like, as we call it, within the software. You're able to fly that survey over and over and over again in different times, in different seasons, at different, for example, pressures and different circumstances, so that you can really start to understand the richness of what you know of the issues, and because you can do that, you're able to make better decisions. The second one there on that, I mean, that's a really important one. I mean, if you're dealing with gas in most forms, that you know, if they're very harmful, they're not just if you breathe them in, but also if they ignite. So being able to keep somebody out of harm's way, where you can write into your plan, maybe you're trying to meet 14064 through some kind of certification service. You can write in there that you're using this new technology. You'll keep, and you're ticking all the health and safety boxes. You're keeping people out of harm's way, which is the main thing. So that's a really important aspect of drones, in as much as they can go into places we just simply wouldn't want to do. The third one there, minimizes expenditure on planning regular surveys. I mean, with my experience, I'm aware that certainly on petrochemical sites, if we've wanted to do an inspection, like an ultrasonics inspection or some kind of reading, then in a lot of cases, trying to get to the top of, let's say, some kind of pressurized container, you would need scaffolding put in place at great expense. And it's surprising how expensive just to tick all the HSE boxes, just so you can get somebody on to do a survey. And obviously with a drone, you don't need to put that in place. Some of you might be aware now that there are ultrasonic drones out there where you can, they're doing ultrasonics, but again, that's a bit of a game changer, because it means that you can do a sort of almost like an inspection on a coating inspection. You can do it with without actually having a person at the top of a silo, for instance. So really good. So yeah, it minimizes expenditure. Your drone, you can get a drone up above, around the infrastructure, and you don't need to worry about scaffolding, which is great. The one that I've got in there is satellites, and the satellites certainly can't through sea clouds, and there may be some cases where you might have relied on satellite imagery before, but if you need to turn around decisions, sometimes it's much quicker to put a drone up in cloudy conditions. It might be that something was missed, and you can get a second opinion. So again, really good benefit that you can put these drones up in cloudy conditions. Very, very quick to set up and deploy. So yeah, I mean, you can do all your planning for your mission before you even get to site. With a few touch-ups up on site, you're basically getting the drone out, getting your controller out, checking that everything is okay, and then you're able, with the permission of the site owner and operator, you're able to go and do it. So it's great. As I was saying before, drones can access difficult places, so you're keeping people out of harm's way, but also these places are not just harmful, they're actually difficult to get to. So at the top of a silo, unless you are going to get scaffolding out at great expense, it's very difficult to get somebody there. So being able to get a drone to go up there on a regular basis within a centimetre accuracy each time to do a repeatable survey is a really good thing, because it means you can get to these places quite easily. Like I was saying, on all the other on the three technologies that we looked at, the live feeds and the reporting functionality of the software now is coming on leaps and bounds, trying to keep up with the different technologies. So again, if you are procuring services, then you need to think about how that's going to help you, and we will touch on that a little bit later. So that'll be covered. Providing actionable insight. I'm going to go into that a little bit further in one of the slides coming up. But that's really about helping site operators make the right decisions on sites, and drones are able to do that, and partly because they can keep doing a survey over and over again, sorry, and you can see the differences. Drones, also the last one on there, survey speed. You can do a survey a lot faster than you would on foot, mainly because a person on foot has to go through, he's not exactly going over the hurdles, but he's going around infrastructure, having to potentially get permissions to go into certain areas, where a drone can fly above or around the asset and still get the relevant data. So it can be quite cost effective as well. Next slide. So I talked about actionable insight, and there's some what I mean by actionable insight is that, as you will all be aware, if you're an operator and or site owner, you'll know that we pretty much work on a permitting permits are very much a really important part of being a site operator, and being able to operate, and being able to identify where repairs need doing, where plant upgrades are required, or retrofits, or even changing of your different procedures on site because something has been overlooked or it's been missed. That's really, really important, and the technology that will enable you to do that is what a drone does. It's what a drone is. So the drone technology will allow you to see over a site, and we'll be able to see, for example, be able to identify where leaks are. We'll be able to identify where perhaps things have been done where they shouldn't be done, or might need changing slightly. So whether it's an open source or like a landfill site, or a closed source like a treatment works, on a pressurized container on a petrochemical site or an oil refinery, then there are always ways that drones can help your team see changes with regular surveys, which can be accurately repeatable. So you're getting apples for apples every time. Next slide. So yeah, I wanted to put this slide in just really to sort of give you an indication of what if you are a site operator or a site owner or an operator, then give you an expectation of what the cost will be. So so whether it's SNF, OGI, or TIDLAS, an order of magnitude, 1,000 to 1,750, I think is the kind of figures you'll be talking about. To be honest with you, anything below 1,000, I'd be questioning in the amount of methodology. I think that a lot of these companies that I'm aware of I've put a lot of effort into making sure that they're ticking all the boxes they need to and delivering a first-class service. And obviously, they need to recover that cost. So I think that you're going to get a quality service around that kind of area. So it's just a bit of a heads up, really. What I would say is that would be a full that is obviously for full analysis as well. So you'd expect to get not just the data acquisition, but also some kind of reporting, some kind of output that will allow you to make better decisions. As I've said there, if it was simply data only, then somewhere in the £750 to £1,000 mark, yeah, okay, that's fine. If it's just data only, but a lot of the R&D has actually gone on the reporting side of it. So and the methodologies, and that's where I think that you expect to see prices between 1,000 and 1,750 for this kind of service. That's per cost per day. So in terms of coverage, I've got this particular one is I've picked this out for it's actually TEDLAS, but you'd expect to do let's say a 10-hectare landfill site in about 1 hour and 25 minutes. And not particularly quick speed. but it again much faster than a human being, and of course it doesn't get tired. So you've got data accuracy. As I've said, also at the bottom there, excluding travel, accommodation, and subs, and excluding VAT. Okay, next slide. So it's just setting scope. Yeah, okay. So this is about scope and procurement. I wanted to put some considerations in. So if you are a site owner or operator and you're looking to procure these services, sort of things you might want to look out for as they are start of attempts. They're just things that I feel can be overlooked quite easily, but are really helpful for you to get you in a good place. So yeah, next slide. So the first consideration I've got here is when you're looking to procure these kind of services, just remember that drones, in the most part, will not fly in rain. And when the wind is above a certain wind speed, they can't fly either. So just bear in mind that, and you'll need to talk to the provider, or obviously it's something that you can email me afterwards, and I can give you some data on kind of what kind of wind speeds. But it depends. It depends on a lot of factors. But just bear in mind the weather plays an important part in a drone survey work. So because of that, you should plan in your schedule some backup dates. So don't just think it's gonna be one shot and it's all gonna get sorted, because it's not like when you're on the ground and you can just go and get, oh, it's raining, so what, we're inside anyway. We're not, we're outside. And in a lot of cases, it's best if you want to get good data, you need the best conditions. And I think sometimes it's just good to just put in some backup dates. So you're saying to your service provider, okay, so these are the dates we plan for as the first, as the primary dates, but then what would be the backup secondary dates if that couldn't go ahead? If they're a good service provider, they should be keeping you informed anyway. They should be telling you. I'm telling you in advance, I mean. So yeah, so also, which is a good idea, is to organise a reconnaissance day, and just to meet the site. And I've said here, I really recommend flying a demo. I like to do that with all the customers that I talk to. The first thing that I want to do is go and fly a demo, and actually let them see it, let them almost understand how it works, and get a good feel for how it's gonna benefit them, because usually they can see it pretty much after a sort of a morning flying and talking about it. They kind of like, yeah, okay, this is going to work for us. So that's something that you should just bear in mind. If you do, like I said, if you're a site owner or an operator, think about getting a demo, getting to meet them, and trying to gauge where they are. Also, when you get when you get a plan and some survey time, make sure that you sanity check it, go through it, and make sure that in your head that makes sense. It doesn't take sort of too long. You can quickly go through the flight plan and understand how fast they're going to fly something, or what area they're trying to do. So don't just take it their word for it. Make sure that you do sanity check it, because it's mistakes do happen. It is human error. So sometimes it's nobody's fault. It's just sometimes you just miss something, and so it's just better to be safe. So also what I've got here is it's kind of like, I suppose, it's sort of linked to the way with survey making sure that its schedule is right. But if you've got a large area that you've got to do, I mean, I like a landfill site, a large landfill site, which might be 200 hectares, then you've really got to think about the right drone for the job. So like I was talking earlier about the M300 RTK, and and if you want to write that down, M300 RTK, that will give a really good flight time. It's a standard now, and then you would it's not, if you've got a large area and it's not quite on the scale of getting a fixed wing, where it'd be like a plane, which there are some sites in the UK that are really, really big, and it'd be much better to fly a fixed wing. But in majority of cases, you don't need a fixed wing. You would probably use one of these long flight time drones, such as the M300 RTK. So just bear in mind that if it's a large area, you need to make sure that they're using a drone and they're not changing batches all the time, which again is not doing the survey, but it's costing you money. Yeah, last one on this slide is, yeah, just be mindful that some airspace is restricted. There are some restricted airspaces in the UK around different military bases, for instance, around nuclear facilities, power generation, etc. And you need to bear in mind, if you are near one of those, that they are taking that into account. So I've been to a couple of sites now where we want to do the whole site, but we weren't allowed to do the whole site because it was a restricted area, and that was partly timing as well, because there was things going on. The other thing just to say on that is that also bear in mind that that the service provider will be also needing to talk to air traffic control as well. So if you are near an airport, or again, it's like an RAF base, then they would need to be taking that into account as well. Next slide. The next one here is that if your site is a very complex site, feel good with them in regards to getting the RAMs right. If it's a complex site, there can be quite significant RAMs to fill in, and so you can usually tell the quality of the provider by what their handle is of the RAMs. If they seem to be fluent in RAM speak and are able to answer a lot of your questions, then you're probably in good hands. But just bear that in mind, that there's a wide variety of service providers out there, but you're best making sure that you're happy that they're familiar with the RAMs that you'll need them to get involved in. That comes from a lot of experience as well, of course. So as I said, the next one, being able to see their reference list is also probably a really good thing as well. Now, if you're going to be forking out thousands and thousands of pounds on, it might be 2 or 3 or 4 or even more of these surveys, you need to make sure that they're not just setting up, that they've done this before. They've got a good reference list, so make sure you talk it through with them, that'll be good. In terms of outputs, yeah, I would just say, just leave nothing to chance. Talk it through with them. Make sure they understand what your expected outputs are going to be and why they are. So what problem is it you're trying to solve, and be clear with them on that, so that there's nothing left to chance and there is no guessing game. So that should be communicated as early as you possibly can. Yeah, that's a really good point there. In as much as if there are outputs that they've done in the past, they should be able to provide that with the references as well. So what references have you done, and could we have an example of your outputs, please? Because we'd like to see that compared to our problem. How is that going to help us? What I do find in a lot of cases, certainly with the providers that I work with, is that they create that sort of cherry on the top. They're able to work with that and give you a little bit extra than what they would have done, and because that's innovating for them, it helps them as well. So I would say that the sort of the main service, you don't want them to be messing with that, because that's something they should be delivering it day in, day out, and be able to do that in a well-oiled way. But sometimes the bit on the reporting side, that might be something they can do. So always look out for that as well. Yes, second from last, yeah, make sure that you understand your gas source. So is it open or is it closed? If it's an open source, it's going to be something like landfill site, sewage works. Closed site would be, it's a closed pressurized system, like a pipe system or a pressurized container, cylinder or silo, where gas is kept and it might be leaking out. As we mentioned earlier, OGI is very suited to that kind of closed environment. TEDLAS more for the open sites. But just be aware of what yours is, open, close. It might even be a mixture of the two, in which case you might need two technologies and maybe even two service providers. So, you know, just bear in mind what it is you're trying to achieve, what your objectives are, and what source you've got, and you can choose the right technology for that. Often drones hand in hand with traditional methods. I mean, yeah, I mean, drones, you know, they are, you know, you've got to bear in mind that there is no silver bullet. Drones can work very much hand in hand with other, with what you're doing already. And that's something that I will touch on in a little while as well. So yeah, just bear that in mind, that it might not be, oh, we can't use drones because, oh, it won't do everything. It might be that actually you can still use drones. It will help you on your site as an operator, but you can work it alongside with what you're doing already. Next slide. So a quick case example. So this is a landfill site, and it's methane leak detection and mapping. And the reason for this is I've done a lot of work in this area, so it's something that I can really talk about. So yeah, let's just next slide. So landfill application, there's lots of ways that we get emissions or fugitive emissions from landfill site. Poor quality capping, so where you've got caps that are keeping the gas in, they cut, you know, they come loose over time, the leaks appear, and the gas it seeps out, the methane just seeps out of the capping. We have minor fissures, so sometimes you basically have a large digger or even a truck, you know, or the rubbish tip trucks that come over. They damage the cap, and then you've, as you can see on the right, you've got a big hole or a small hole, or it's somewhere where it's basically been the cap's been punctured. So that's you know, not just minor fissures but large fissures as well. Leaking gas wells, so where gas wells have been put in, and that, obviously that's where the gas is taken from for the gas generators. So if you've got gas leaking around the sides of those, that's not a good thing. Faulty pipes, yeah, I mean, that's, you know, gas leaks basically, and poorly sealed leachate chambers as well. So yeah, there's a number of areas. So that says landfill, you know, leak detection, methane mapping and leak detection is really important area, and it's going to be a growing sector for the drone industry. Next slide. So yeah, in landfill application, this was an operator with 33 sites. They walked a lot of their surveys. They were basically wanting to get rid of all these surveys. They were doing 2 days every survey. There was a lot of bad quality of data, people getting tired. They were employing people from off-site as well, so it wasn't people that knew very much about what they were doing. They were just basically just writing stuff down. So the quality of the data wasn't that great, and I think they got to a point where they were really looking for another solution that could work alongside their existing processes, and really fill a gap. And in this instance, it was also costing that these surveys were costing a lot of money, and obviously there was a lot of emphasis on trying to reduce this. So next slide. So yeah, so slide before, I think. Yeah. So yeah, like I said, you can do quite a lot. They chose actually, as it happened, they chose a TEDLAS system, a methane system, and this methane system. Why do they use it? As I said before, we're capturing a pocket of air over the whole of the site. Not just what you'd get if you had a person walk over a site and take a reading. That's probably the top, you know, you're only going to get 2 meters depth there. So you're only going to know what the gas concentration is within 2 meters of the ground. So that doesn't give you the full picture. Whereas having a drone at 15 meters, being able to shoot a laser down and see through the whole of the plume, let's say, maybe up to like 5, 10, 15 meters, that gives you a much better understanding of how much gas there is really there. So that's one example. An example of why they thought it was a really great idea for them, because it gave them much better data. They're able to get really good, like I said before, seasonal variations, which is really important for landfill sites. They could repeat the survey over and over and over again. And in regards to the cost, it was less than what they were paying out. In terms of the quality of the data, drones don't, again, as I said before, they don't suffer fatigue. So the data quality was the same. We're getting the same quality of data. Next slide. So just looking at those costs, in essence, the saving was quite considerable. One water survey of the cost of 23k, 2 drone surveys per site per year, 43, total cost 66k, and this saved them a huge amount of money. Savings are 11,000. However, not only did it save them a huge amount of money, they were also getting comprehensive data gathering and a reporting service, ongoing methodology refinement. So the service provider was refining the methodologies and improving things and making things better. They're also able to try on new sensors and sensor capabilities. So they're able to start to see leachate and other things that they can see with things like hyperspectral, all kinds of different trials of sensors that they can do. And as I mentioned before, they're also getting this really accurate replication of surveys over this whole of over the year, so they could look at the data in different weather conditions and see, what was really going on, and giving them a better richness, so better decisions could be made. So not only were they making a saving, they were actually getting an improving service every time the drone survey company went up. Next slide. So so the last few slides are really on future and the technology developments that we can expect. Next slide. So the first one, we mentioned TEDLAS before in the presentation, and TEDLAS is used for the majority of cases for methane, methane detection, mapping. And for those who were keen of you would have seen that before we were using it for the walk down surveys, which you can see here towards the top. Now, what I was working on with other companies as well, in tandem with the University of Manchester, was to create a flux capability, or a flux survey capability, which is a quantification of the emission itself. So it's being able to calculate the volume of the gas that's leaking from the landfill site, and so this technology will save a lot of time and effort, because at the moment it's a considerable amount of time and cost to have people go on the site and do these flux surveys and then calculate the gas that's coming out. So this new way of using drones to do it is going to be a bit of a game changer. So look out for that. So the way that TEDLAS, or the methane laser, is being used is really changing from just being able to map to actually quantify. Next slide. So drone OGI systems, so we're going to see a step change here quite soon. Up to now, we're not really been able to quantify leaks using OGI on a drone, simply because there's been stabilization issues, vibration stabilization issues, and they're going to be overcome soon. I know of a couple of companies that are working on this technology as we speak. So that will give us the ability of a drone to go up and detect the leaks and then quantify the leaks. in grams per hour or whatever measurement you want to do it in. So again, that will be a real game changer, because up to now you've had to have a fixed, stroke tripod based OGI for this stability. Next slide. Next slide. So the last one on here is beyond visual line of sight. I mentioned SF6, which they remember. I was involved, although I'm not involved in it anymore, but I was involved in a project where you send a drone out of a box. It measures the amount of SF6 around the transformer station. It lands, it downloads its data, and that is sent to different people all around the UK for analysis and for monitoring. And I think that kind of BVLOS or DIAB, as they call it, drone in a box system, is going to increase, or the use of these kind of technology is going to increase, and there'll be more providers of this technology as we move forward the next 5 years. So again, that's something to look out for. Very much in its infancy, but something to look out for. Next slide. So yeah, I think that's the end of the presentation. I hope that was a bit of it was a whistle-stop tour, but I hope for those that don't know too much about drones, and you could be a site owner or an operator, and you're looking to get into maybe becoming a pilot or the site's pilot. It's something that you've learned from. Yeah, happy to take questions. So yeah, back to you, Elena.
Stop sharing the screen. Thank you very much. It was absolutely fascinating. And we do indeed have some questions. So let's go straight to those. Okay, it's the first one. Excellent presentation. Thanks, Jonathan. This does seem a technical topic and requires specialist operators. How do we find out about professionally competent operators? So I can tell you a little bit about finding the professional operators. Here at ARPAS, we have a Find a Member scheme with people all around the country who are registered with the CAA, which means they've done all their appropriate training and have all their appropriate certificates. Jonathan, what about the specialist side of things? Can you answer that?
Sorry, Elena, can you just quickly repeat that? I didn't hear that.
Oh, sorry. Yes, we've just been finding that you're glitching a little bit. So I mentioned that ARPAS-UK have a Find a Member facility on the ARPAS website, where you can find ARPAS operators, drone operators around the country, but not necessarily with the specialist skills that you need. How does somebody go about training using such equipment that you've been using? Oh, I think we may just be having.
Yeah, first of all, as you said, can you hear me okay now?
Yes, we can.
Yeah, okay. So you need to be able to fly a drone commercially to start with, and then it's a case of there are various providers out there of equipment. Obviously JBUAS is one of them, but there are others as well who provide this kind of training for this kind of technology. If you are a operator or a site owner, and you're looking for this kind of, and you've made the decision that you want to become a pilot, and your business wants to purchase this kind of technology, then please come and please send me an email. I can point you in the right direction. It's not just about JBUAS, it's also about other providers as well. We have a niche that we can provide, but if there are other providers out there that are in a better place than us, then obviously I'm quite happy to point you in the right direction. What I would say in the first instances, though, my own view is that the best route I don't think the best route is to look to, in the first instance, to purchase to go full pelt into buying your own equipment as a site owner or operator. I think you're much better having getting to know the equipment and the service through a service provider. And there are numerous providers out there that I've dealt with who are very capable. You know, we're not going to mention any of them because it's not about that. It's about, you know, you just come and see when you can. But yeah, there are. I can point you in the right direction, but get to know the technology, understand the outputs that are possible, and then, you know, have a demo, get a small survey done maybe, and then think about maybe further down the line whether actually you're better off, you know, having a service provider or getting it yourself. Because actually what you might find is that you're actually better in a better position having a service provider. Can you hear me? Hi, can you hear me?
We can.
Can
It's
you hear me?
glitching a little bit, though.
Okay. So basically what I was saying there was, to cut a long story short, by seeing the technology from a service provider, what you might find is actually you're better off with a service provider not having it yourself, you know, because you know, you can have a service provider, it's what they do, they can improve the service, they can provide you better outputs, and, you know, and they can do it cost effectively. You don't necessarily have to go and buy the assets yourself. And you know, but of course, later down the line, that might be a decision that that as a site operator, you might, or a site owner or operator, you might want to do.
Indeed. Okay, the next question. Does this methodology lend itself to other sensitive measurements, such as radiation for nuclear?
That's a really, really good question. Now, there are providers out there that will do radiation sensors for detecting radiation. I mean, for when I say that is, I've only been involved in a couple of projects. One of them, which is actually on an old RAF base, and it was to detect radioactive substances that were used in fighter planes in the cockpits. Some of the dials, I think, were use this kind of radioactive substances, and they're left in the ground. And so I've not really had a massive exposure. I do know of people that do this. So again, if you have got a question on that in that regard, send me an email and I can put you in touch with the right people.
Great. How do you operate offshore? How does duration of flights work with hard to access oil and gas platforms and or pipeline installations?
Really, really good question. There's a lot of things that you need to take into account when working offshore. I mean, I don't know who's asked the question, but it sounds like they know a little bit about the difficulties of being offshore. You know, you've got to get out to site for start, and that usually involves a bed, which usually means that you've got limited space, limited time to be out, to go offshore to a certain place, and that's a limitation. So you're very much reliant on the operator or the main contractor to get you that seat. They're, you know, they're almost like seats either on a helicopter or on a ship. And yeah, you've got to work hand in hand with the people that are in the know to get you out there. You know, and of course you've got to have the right tickets to be able, from a health and safety perspective, to do that kind of work as well. It's a very specialist subject, a very specialist area. There, again, I do know of companies who do deliver these services in oil and gas. Again, come and see me. That is something I can help you with. Great.
And I'm just going to remind people this is your last chance to sort of ask any more questions. And while you're typing those up, I shall answer this one. Which of the mentioned sensors / sensing techniques can be used with a fixed wing drone?
So the sniffer can't be the sniffer. I've not come across a sniffer used. It's that particular sniffer that I was talking about. That's not been used on a fixed wing. But I don't see. Yeah, I wouldn't think it would be used on a fixed wing. Certainly, TEDLAS methane, yes. it is used by the manufacturer Pergam do have their own kits that are able to use. Again, I don't want to blow my own trumpet, but I am a Pergam partner. So again, if that is something that you're looking at, then come and see me and I can point you in the right direction. So yeah, a large, it's going to be, so if they're talking about that, they're talking about a large open source, probably like a landfill site, where you would fly a fixed wing over a long wide area. Yes, you can use it in that. They use them on helicopters, so I don't see why they can't use it on a fixed wing. Absolutely.
Okay. And then so two more. A question for Jonathan. While the UK has signed the pact to reduce 30% of GHG emissions by 2030, from your experience, do you see increased use and tests by the UK petrochemical operators? For example, are they going from once a year to quarterly?
Right. So first of all, my understanding in terms of the permitting process for petrochemical is limited. That's the first thing I would say. So I'm not going to profess to know the ins and outs of that. What I expect, and from my discussions I've had from the EA and people within the petrochem sector, of which I still have quite a lot of old colleagues, is that the permitting process is to be ratcheted up. So there will be more of a need for methane technology that is mapping and kind of leak detection technology, such as drones. So I would expect, like we've seen with landfill, where there is new technology, it may not be regulated, but certainly it would be encouraged by regulators and so forth, that they should be looking to try and show within their certification scheme, which I'm guessing they'll be part of, like an 14064, they will want to use that. So I don't know if that answers the question, but
I think that probably does. And I think that may have been the last question. So thank you very much indeed, Jonathan. And thank you very much indeed to our attendees as well for joining us this afternoon. Thank you for being patient as well with some of these glitches happening. Jonathan, are you in the field at the moment? You look as if you're out and about.
I am. I'm in my my VW office, my camper van office. I'm actually at a Roman town at the moment called Brindley, which is sort of Midlands, England, Peterborough, for those people who know it. And we're doing archaeology with a new it's an R4 magnetometer on a drone. So it's drone magnetometry is what we're up to today.
Oh, fantastic and absolutely fascinating. And there you go, another use for drones. Well, thank you very much indeed. There are still some more CPD sessions happening in this series through to the end of March. And indeed, if you're in the UK and would like to join us on Monday in Rotherham, we have a conference in the afternoon with speakers from BEIS, which is the Department for Business, Energy and Industrial Strategy, the National Police Chiefs Council's UAS team, CHIRP, and the Connected Places Catapult Drone Pathfinder. So do join us for that if you'd like to. The sign up for that, the registration for that is on our Eventbrite side of things and has also been posted on LinkedIn certainly too. Thank you very much. These sessions as well will be posted to the ARPAS-UK website in due course, and I will contact all the attendees to let them know where to find them, because there's so much information going on in these that you sometimes do really need to listen back to them again. So thank you, Jonathan. Thank you, attendees, and hopefully we'll see you at some more of these sessions. Thank you then, everyone. Goodbye.
Bye-bye, everybody. Bye.